We're here for a sequel to a panel that we had a year ago at DAC 23, and the subject of that panel was what we called the convergence within engineering software. That is to say, the melding of EDA with the counterpart technologies and markets elsewhere in engineering software as something that had been talked about and anticipated for many, many years, but which had become increasingly evident in terms of company strategies, such as from Cadence's move into what they call intelligent system design. And since then, of course, we have had the very significant news of Synopsys's planned acquisition of Ansys, which in many ways is a $34 billion exclamation point of this point regarding convergence. And so we're here with mostly the same companies, a couple of new participants. I'll read out the bios briefly, but the idea is to explore what's changed in this trend, this phenomenon over the last year. Let me just do the bios quickly first, and then we'll commence with the questions. So I'm going to introduce the participants in alphabetical order by company, starting with Tom Beckley on your left. Tom has served as Senior Vice President and General Manager of the Custom IC and PCB Group at Cadence since 2018, including responsibilities for IC packaging and system analysis. Tom joined Cadence in 2004 via the acquisition of Neolinear. Tom's business units accounted for over a third of Cadence's revenues in 2023, or nearly $1.4 billion. And its system design and analysis segment is responsible for the company's expansion into products and markets adjacent to EDA via the aforementioned intelligent system design strategy. To Tom's left, Philippe Laufer has been Executive Vice President of 3DS Global Brands at Dassault Systems, with responsibility for all of Dassault's brands since 2020. He has also been leading the customer engagement teams, the field, since 2021. Philippe began his career at DS in 1985 as part of CATIA Research and Development. Prior to his current role, Philippe was CEO of CATIA, Dassault's largest engineering software brand, with $1.2 billion of revenue last year, and by the way, the largest CAD brand by revenue in the industry. He is also the relationship manager for Dassault's partnership with Cadence, at which his counterpart is the aforementioned Mr. Beckley. Funny how that works. Moving on, Niels Faché is Vice President and General Manager of Keysight, responsibility for the EDA portfolio at Keysight, and now as well for its expansion into the broader world of engineering software, such as with its recent acquisition of ESI. Niels joined Keysight in 2014, prior to which he worked in senior management roles at Agilent and at HP in Ghent, Belgium. Mr. Paul Sager is Vice President Product Management at PTC, formerly Parametric Technology, many years ago, with a specialty in CAD, namely the company's Creo brand, formerly Pro Engineer, Creo Elements Direct and MathCAD. Paul joined PTC in 2005. Creo is PTC's largest software brand, with revenues of more than $600 million last year, and has, according to our research in recent years, gained market share as measured by growth of active base users in the last several years. From Siemens, we have a very welcome repeat appearance by Tony Hemmelgarn. Tony has been President and CEO of Siemens Digital Industry Software since 2016, having joined the company 15 years ago. Siemens Digital Industry Software had the largest total revenues in engineering software in 2023, including Teamcenter, the largest PLM brand, and of course Calibre, which ought to be well known to this audience. Followed closely, by the way, in terms of total design automation revenue by Synopsys last year. Previously, Tony served as Executive Vice President of Global Sales, Marketing, and Services. Prior to what is now Siemens' software business, he was with two predecessor companies, EDS and SDRC. finally, one of our new panelists, Shankar Krishnamurthy, is the general manager of Synopsys' EDA group. He is responsible for the EDA software line of business across design, verification, sign-off tests, silicon lifecycle management, TCAD, and manufacturing domains. Before rejoining Synopsys in 2017, Shankar served as GM of the IC Design Solutions division at Mentor, joined Mentor in 2007 with the acquisition of Sierra Design, where he was founder and CTO. Okay. So I'm going to start with Shankar and refer to the pending acquisition of Ansys as perhaps the most significant news in the industry over the last year. We're not going to ask about regulatory matters or anything of that kind. We're going to ask about strategic rationale. And the question is, as recently as a year ago, notwithstanding the half-dozen-year relationship that by then you'd already had with Ansys and by which you'd already gotten to know each other quite well, it was, at least to me, not entirely evident that Synopsys was thinking a great deal about this intra-engineering software or inter-engineering software convergence phenomenon as something that was motivating your strategy. And here we are. And so perhaps the two-part question, I always have to ask a two-part question, is what is the strategic rationale? What impelled your thinking over the last year? And part two, what are you thinking of doing, or how are you thinking of leveraging the 4/5 of Ansys that is not EDA, you're having been most associated with the 1/5 of Ansys that is EDA?
Okay, so let me start by kind of framing the landscape around us, right? We are hurtling into what we believe is the era of pervasive intelligence that's driven by AI, silicon proliferation, and software-defined systems. So in this landscape, what we are seeing is, we are seeing silicon companies, and you mentioned it in your opening, NVIDIA, for example, becoming a systems company. Not only do they deliver a chip, they also deliver a rack, they are also delivering a cluster, and of course all the software on top of it. We also see a landscape where a system company like Microsoft is reaching deep down and building silicon for AI accelerators, DPUs, CPUs, and so on. So what we really see is that the silicon engineering workflow and the system engineering workflows are essentially beginning to overlap, and that's really where we see that EDA and simulation analysis markets now starting to converge. So if you look at it from a silicon lens, we are rapidly moving towards, by the end of this decade, a trillion transistor system in an advanced package. And to realize that, our customers are driving us to basically deliver a next generation advanced packaging environment where you can basically deal with that type of capacity and have an integrated environment for exploring, constructing, and signing off these large advanced package systems. So from our perspective, we already have the strength in the Synopsys portfolio to deal with the exploration and the construction based on the fusion architecture that we invented. But on the analysis side, our partnership with Ansys essentially gave us the opportunity to bring in the world-class multi-physics capabilities of Ansys into our environment, and thereby try to solve this problem in a holistic fashion. As we converge towards this end of this decade, the deep fusion that is necessary between all the electrical analysis and the multi-physics analysis is going to be very consequential to solve one of the biggest problems that we have with multi-die systems today, like cracking and failures due to issues like thermal and mechanical stress. And it needs to be deeply integrated, and it needs to be left shifted, just like we have left shifted all kinds of other analysis in the EDA workflow. If we now look at it from a systems innovation lens, we've been investing in systems for the past several years with areas like silicon lifecycle management, for example, which is now a very fast growing business for us, as well as by building a very strong business around building electronic digital twins, essentially models for the underlying hardware to enable early software development. So as we have engaged with those customers and they have used our electronic digital twin capability, we are also getting those customers driving us towards how do you make these electronic digital twins work seamlessly with all kinds of other virtual twins that a system might have, like mechanical twins or twins of the electrical systems and so on. So we really see this opportunity to really work across the whole industry to build what is called as a virtual twin of the system. And with partners and with other collaborators, this is absolutely feasible. And I'm sure Philippe from Dassault will talk about it, as will Tony, that opportunity to build this system level virtual twin to enable virtual product testing and virtual product development, which promises to save millions of dollars of costs as well as improve the quality of the products that are delivered. So this is really how we see these worlds coming together. And let me just leave you with one data point that should really make this very, very apparent. From our research, it takes about 18 billion miles of testing to achieve ADAS level 5 autonomous capability and to pass the different certifications. And we don't believe that 18 billion miles is all going to be tested physically on the roads. So you really need this virtual environment for product testing and product development to become a reality so that you can dramatically reduce the time it takes to deliver these intelligent systems to end markets. So this is really the thesis for why we've gone in this direction.
So Tony, where Synopsys is the newest in pursuing this convergence phenomenon, albeit the largest, you are in many ways the oldest company, that is.
It might work both ways.
And having been pursuing this now for 17 years and 1 month. And so perhaps you could talk about what's changed in your thinking, your approach, if anything, over the last year, as to interesting examples of convergence in terms of either products you've introduced or products that have been adopted in critical end markets that are really concrete examples of the C word.
So much of what was just said, look, we saw this 7 years ago when we decided to bring together Mentor and what we're doing. And I agree wholeheartedly with everything that was said about bringing these virtual and real worlds together. And while it's important to do it with the CAE capabilities, which we've done as well, that's necessary, but it's not sufficient. Because if you're going to have a digital twin, there's a lot more to a digital twin. You know what I mean? And as said last year in this panel, the value of the digital twin is how close you can make that virtual world represent the real. The closer I can make that, it's the more valuable to our customers, right? And so it's not just what we do with CAE, it's what I do with 3D design, it's what we do with manufacturing simulation, what do we do with data management, how do we bring all these worlds together? And so, since I've been in the role, we've done 37 acquisitions of companies, now some small, some bigger, and all towards that goal of how do you bring these worlds together? Because again, that's what our customers tell us where the real value is. If you design the product and then you can't represent the printed circuit board in the design process, or you can't represent the manufacturing processes, they look at us and say, yeah, but where do I go with this? How do I make these decisions in parallel? So for example, one of our customers, one of the largest consumer packaged goods companies in the world, designing those earbuds that go in your ear. That printed circuit board that goes in that bud has 43 bends. 43 bends in the printed circuit board that has to fit in there. And you've got to put a chip on it in a place that's not on the bend. And then you've got to worry about the thermal characteristics. And then somebody's got to manufacture it as well. But by the way, you also have to design a 3D enclosure around it. So that's what we do with our software. I have 3D packaging capabilities to design the product. We've got the printed circuit board capabilities. We've got the integrated circuit capabilities that we bring to the customer to be able to do those things all in a simultaneous way, because really, I mean, it's even like the name of this event, it's the systems conference. That's what we hear over and over again from our customers. Whether it's in that space or what we're seeing in aerospace and defense, or wherever we go, designing radar systems, these types of things, they're constantly looking for us to bring those worlds together. And so what we've tried to do is keep building that out. And I would argue the digital twin is not a new concept. It's been around for a long, long time. It continues to evolve. as to what you mean by it. And I would argue you're never finished with the digital twin. And so as a company, we will constantly look for how do we build that out more to be able to help our customers in those kind of examples.
Okay. So for the third question, I'll turn to Cadence and Dassault. So Tom, Philippe, in the case of Synopsys and Siemens, they've each made or about to make sizable transactions or multiple transactions over an extended period of time. Each of you, of course, has been an acquisitive company. Tom in particular with the ISD strategy, and Cadence, of course, moving into computational fluid dynamics. But your approach is also different in the sense that you do have this partnership.
Right.
And so how do you see the role of this partnership? Maybe give us an update on how it's been performing, how it's advanced over the last year since the last panel. And do you see partnering as an alternative to acquisitions, or maybe expand on how you're thinking about the execution of this partnership, but also at the same time how you're thinking about otherwise implementing this strategy and this phenomenon?
That's great. Well, I'd like to echo what Tony and Shankar said. I think I use the term cascading complexity. What's happening at the chiplet level all the way through the system level just continues to intensify and make it more and more challenging for companies to get their products to market on time. And Cadence has been on this kind of multi-physics electrical analysis journey now for over a decade. And frankly, 8 years ago was my first meeting with Dassault. It just shows you how long we've been talking. I think over the last 4 to 5 years, our partnership really unfolded and intensified, and I'll talk more about that in a minute. But I think we all know that Moore's Law is still alive and well. We are seeing 3 nanometer in production. We're going to see 2 nanometer in production pretty soon. 1.4 is going to follow that. But everything is going to start moving in a 3D fashion. Everything is going to get more vertical. We're going to integrate GPUs and CPUs and high bandwidth memory and sensors and photonics. It's just going to become increasingly difficult. And then we're going to package those up in maybe a 3D IC and maybe a system in package. They're going to have massive pinouts. Those massive pinouts are going to take that complexity into the world of the boards. It's going to take that complexity into the world of all the mechanical system around the electronics. And that's really what our customers, I think, collectively want us to solve, is how do we handle things like thermal integrity that Tony had talked about, how do we handle radiation, signal and power integrity? How do we trade those off from the chip through the package, through the board, and across the entire system? And that's precisely what our partnership is about, is by partnering together, by developing an ecosystem where we leverage our strengths together, we have the opportunity to allow companies to use the best-in-class mechanical design, PLM, all kinds of systems, especially system design modeling that's also unfolding, and to do it in a cloud-based 3D experience world. And we started with a couple enterprise accounts, kind of focused on Allegro X with integration into PLM and into mechanical design, but we quickly expanded into small and medium businesses. We touch our enterprise sales teams, we touch our channel partners across both, we've trained both. It's really quite an interesting partnership. And right now we're kind of looking at how do we integrate next generation system modeling and analysis capabilities like Cameo and CATIA Magic and more. And maybe you want to comment a little bit, Philippe.
Yeah, I would. Does it work? Yes. So I would like to comment on the strategy that we have been conducting since, by the way, 2012. In 2012, we announced that we would be the 3D experience company. And this word, I've been missing it in all what we know in the past years. Our clients are not delivering products anymore. It's not enough. They're delivering experiences. And as such, of course, all disciplines need to be integrated and not having simple interoperability with files. They need to be integrated to be able to simulate this experience. We see that, by the way, also accelerating now from our systems client. And they are now entering in the silicon business.
Yeah. Yep.
So this is a trend that we're seeing every day. So the strategy that we have is to help our clients move to the experience economy, to have them become a factory of experiences. You know, in transportation mobility, I often still see people speaking about software-defined vehicle. That's a mistake. It's a mistake. In all the vehicles, you know, in majority of the vehicles, they have lost already against this, because this is not a software-defined product. This is a software-defined experience.
Yeah.
So in the past, the digital markup was the context. Today, the experience is the context. And this means integrating all disciplines that are contributing at the end to the experiences. So Shankar, you talk about the silicon twin, for example. Tom, we're doing together the electronic twin integration as a contributor to the experience. Furthermore, it's not only the virtual twins, and we call it virtual twins, not digital twin, because digital is digitizing the present. We are virtualizing the future. And we do this with the what, the product and services, the how, the production systems, and the who, the enterprise and the value network. Last point of the strategy is what you said, to structure, orchestrate all the disciplines like EDA, mechanical, electric. You need an overarching systemic view.
Yeah.
And we have delivered, and it's in use today, cyber system solution that have become the de facto standard in system modeling and simulation. Once the system architecture is in place, it dramatically enhances the quality and the automation of the discipline development. So all what Cadence has done, for example, AI generating PCB, is overarched by this specification that are in the system functional and logical view of the product. So we have many examples. We have in the United States supersonic, maker company in aerospace that is using this system view, and instead of doing then typical electrical schematics, they are generating, thanks to the system view, this schematic automatically from the system view. And this is what we want to do as well with Cadence on that topic.
Okay, thank you. Paul, the strategy that PTC has articulated the last number of years is in many ways synonymous with convergence, closed loop lifecycle management, which we've certainly said in our reports is an appealing strategy, bringing together your various functional classes of software. So what is the company's general view of the convergence phenomenon, and how you're approaching it through your defined strategy? How does it affect your development? How does it affect your acquisition strategy?
Okay, so firstly, I'll start off by saying I agree pretty much with everything that's been said here so far. Tony's point of electronic design, it's not good enough just to design a circuit board, right? The circuit board exists inside something. You've got to have the tools to be able to build the enclosure around it, to be able to simulate the circuit board, simulate how that circuit board is working within its environment, etc. So from our perspective, our strategy has always been to have a very, very tight relationship between the MCAD disciplines, the CAD disciplines, the mechanical engineering, and the electrical engineering. So we provide a very open environment. We work very closely and partner very closely with companies like Cadence, like Mentor, and many, many others to make sure that the electrical engineer is able to collaborate quickly, easily, effectively with the mechanical engineer, and vice versa. Taking that one level further, I would say it's also not just about the electrical and the mechanical. More and more in today's world, it's also about the software as well, right? Every circuit board has firmware on it in some way, shape, or form, and so you can't just manage the life cycle of the product. The product now, in a lot of cases, is made up of a lot of software as well. So you've got to be able to manage that software on top of that, which is why PTC's strategy now has been to invest in application lifecycle management with the acquisition of our Codebeamer product. So now we have the ability to manage all of those requirements up front, manage all of the software, manage all of the testing validation programs of the software that is embedded on those circuit boards. That then feeds into our closed loop lifecycle management. So you've got application lifecycle management feeding into our product lifecycle management, which then feeds into our service management. And then from service being able to close the loop back into the very beginning, which is requirements. So we have that full closed loop of requirements into product, into service, and back again.
Okay, thanks, Paul. Niels, around this time last year at DAC, you had completed or were about to complete your ESI acquisition. What was the rationale for that first move crossing the threshold outside of EDA? And how far do you mean to go in terms of emulating the strategy of some of your peers and becoming more expansive in terms of your overall portfolio, not just in EDA?
Yeah. Thank you, Jay, for the question. So our strategic focus is on addressing product engineering complexity, from systems to components, from design to manufacturing. And we do that with application-specific workflows and capabilities that connect and automate processes. If you look at Keysight, our portfolio historically has been focused on high-frequency, high-speed design. Applications included, RF modules. And there's a reason for that. It's very symbiotic with what we do on the test equipment side, where we have to design transmitters and receivers. And so that symbiotic relationship has existed for 4 decades. Now the world is changing. Products are more complex systems. They're no longer purely electronic designs. They involve many different engineering disciplines, multi-physics, as the other panelists have already mentioned. That also has an impact on the product development lifecycle itself, which is more complex, which really needs to be digitized and digitally transformed. And so that's why we've made a couple acquisitions in the past year or so to really bolster our portfolio. We acquired Cliosoft, a company focused on design, data, and IP management. So that really helps teams better collaborate and automate processes. And as Jay mentioned, we also acquired ESI. And with ESI, we bring new application verticals in the portfolio, including passive safety testing for vehicles. So that's crash testing. We have new multi-physics capabilities with mechanical, vibration, and acoustic analysis. We also have capabilities for smart manufacturing. So we're building out a portfolio of multi-physics capabilities with the intent to focus it on particular applications. We're obviously a smaller player than some of the other players represented here, so we need to focus. And so we focus on applications where we believe we have best-in-class technology, where we have deep application expertise. Think about our core business, how well we know transmitters and receivers from our test equipment business. Same with ESI, 50 years of experience with crash test simulation. So the application expertise is really key. We build it into workflows that are automated. We either build these workflows end-to-end ourselves or we work with partners. So partnerships, open ecosystems, are very important to us. So we'll continue to do this and really focus on application-specific workflows and then automating the design and manufacturing processes.
Okay, thank you. So that's pretty much the company-specific questions I wanted to touch on. Now we'll talk about more of the general questions for everyone. In my presentation before this, I made some remarks about AI and ML, which may or may not have been valid, but we'll ask about that. So for each of you, starting with Tom and then concluding with Shankar, do you think that AI, ML, functionality or branded products will always remain distinctive and separately sold, batteries not included? Or do you think that AI, ML will over time simply become subsumed within the product portfolio, as we've seen other classes of technology that start out as distinctive and unique and incremental, ultimately becoming just part of the functionality and the landscape? So why don't you start, Tom?
Yeah, so I guess a couple comments. First, I would kind of put LLMs and AI into one category, and I'd put kind of generative AI and machine learning into another category. And I think from our perspective, we believe that generative AI and machine learning needs to be heavily math and science-based, math and physics-based. And because of that, we are assuming and expect that it will become a natural course of becoming the products over time. Frankly, we've been integrating some of this for more than a decade. What we didn't have was GPUs to drive it. What we didn't have was the high bandwidth memory to drive it. And what we didn't have was the data to drive it, right? So all of that, I think, is starting to unfold. I think the challenge is to enable this across the system. So the trouble I think that semis face, that system semis faced, is that they may optimize their chip, they may optimize their package, they may optimize their modular board. But how do you optimize the system in the context of the experience that you want to have? And so for us, one example is we have a product that we came out with a couple of years ago, Optimality. Optimality looks at the subsystem level and the system level, and we'll take something like what Niels just talked about, maybe PAM4 high performance SerDes. I can use MediaTek as an example since they use the product. For their latest, what they do is they use Optimality in the cloud to optimize critical signals coming off that chip through a package across a board to another chip and back around, and they optimize it in 19 trials versus 625 manual trials on their latest design, and the performance improved by 75%. That's the design space exploration challenge that is unfolding across the chip, package, board, and system. And we need AI, especially generative AI, and we need to, if we don't have sufficient data, then we need to use initial training data and create synthetic data to have sufficient design space to explore with it. So that's kind of where we're heading.
Okay, Philippe.
Yes, let's frame the question of AI. First, AI is leading to what we call a generative economy. It's in fact the convergence of the experience economy I treated earlier and the circular economy. So, and what we want to do with generative AI, because I call it not AI but generative AI, is inspiration from life. We want to mirror the generative method of life. We want also to shift from a linear way of doing, take, make, use, to a cycle of life approach. So in fact, AI for us is the prolonges the virtual twin experiences. We do not want to deliver only co-pilots, AI, LLM co-pilots. We see often companies that are losing their SAO and IT budget, chat GPTizing their engineers. We are merely thinking about delivering generative models, generative simulation, and powered by their patrimony, which is the data. Speaking about the data, the ambition is to elevate the data, and this is the complex topic, to elevate the data to knowledge and know-how. And for that, you need a corpus in the enterprise. And what our platform aims to do is to define this corpus. So we give examples. In the previous session, you mentioned about delivery. We have delivered in fact 24 data sciences and generative applications. And I'm going to illustrate some of the examples. So turning drawings or scans into physical parts, for our physical parts into CAD models. We call these generative assemblies. Enable the discovery of new generative materials, which is also very, very demanded by the system clients for battery, for example. We have been able also to unleash tens of thousands of hours of mission of critical defense assets, thanks to generative sustainment. The other one I want to give you is the last one, accelerate the introduction of new treatment to better serve the patients. We call this generative therapeutics. This is all using our generative AI technology. And again, we see that the system view of the experience is providing the profound prerequisite to be able to trigger those generative disciplines, generative experiences.
Okay. Yes.
Yes. So it's likely a blend of new capabilities and enhancements to existing products. For example, when we think about creating new models, say models of devices, typically they're based on equivalent circuit models where the parameters are optimized against measured data. Today we can use neural networks to build a relationship between input and output variables. We have a whole methodology around managing the data, extracting models from the data, verifying the model, and then deploying it. That's a capability that our customers want to use. So we envision deploying MLOps workflows for customers. That would be a new capability. On the other hand, when you think about optimization, you can use new optimization technologies, deep learning, that enhance existing optimization technology. So that could be a capability that is added to an existing product. When you think about health functions, there you can come up with more intelligent mechanisms with chatbots that replace traditional health functions. We also envision tools that help customers make easier setup simulations. So these are all capabilities that elevate customers' design intelligence that would augment existing products. And then, of course, there's the whole class of generative AI, would be new capabilities around tapping into existing IP to come up with new designs. So likely a blend of new products and enhancements to existing products.
Paul.
So yeah, so I agree. I was going to say a very similar comment. It's a blend. AI is out there to really solve a number of different challenges. But as an example, on one end, it's about making users more efficient, making them more productive. And for that, it's about, okay, the existing tools we've got, how can we provide them in a more efficient way? How can we enable the users to get their job done quicker and faster? And we've already got AI capabilities that have been built into the product for 10, 15 years. We've just not called them AI, right? But then on the other hand, there are ways where we can really take a giant step forward by being able to better understand the data, being able to gain insights that we maybe weren't aware of in the past, because we just never looked at that amount of data and been able to come to certain consensus from it. But the key critical piece that we're focusing on ourselves at PTC is making sure that we're doing it in a secure way, right? That the data is the company's IP, that it's not in a way that it can maybe leak and other people can get access to that data. So it's got to be secure, it's got to be relevant, and it's got to add significant value to the business and to the users that are using the product. So I see both areas. I see us continuing to expand our core products by integrating AI and then introducing new products that can help push that needle.
Sorry?
Yeah, instead of piling on with the same part, I'll take a little bit different direction, and that is, sometimes I'm asked, is this AI space overhyped and where we are? And I said I've seen a lot of things overhyped in the industry over the years. I mean, I think of things like additive, IoT. They were overhyped. They're still coming. They're still valuable, but they were way overhyped early on. This feels different. And it feels different because we're delivering things now. The opportunities are endless. And I think if we're not building them into our core products, somebody will. And so I think it's going to go into the core products. For example, you recall, I think this was in 1997, RASNA announced they were going to put CAE in the hands of the average engineer. It
MSc
never
before
really
that.
happened.
Yeah.
It never really happened. It still was at the PhD level. Right, so now we look at that, and we're showing today, with our CAE tools already today, I can go in and say, one of the biggest problems for a CAE model, the reason it goes to a PhD, is putting the boundary conditions and the load conditions on. If you don't get those right, nothing else matters. Using AI, I can get them right, and I can bring them to an engineer that may not be the PhD expert. So we have many examples of these types of things we're doing in our core products. Automatic generation of a bill of process for manufacturing, automatically through AI. I can go on and on, the ones we're delivering today with our customers. But then I think about new opportunities. So for example, we're doing a lot of work with NVIDIA with Metaverse, and what a Metaverse means and how do we do this. And so one of the things we've shown is flying through the factory like a gaming engine. I can go wherever you want to go. I know everything about that factory. I know the product that I've designed to go into the factory with our tools. I've simulated the factory, the flow, the bill of process, everything about it. I'm running the factory with our automation capabilities, gathering all this data. So now, the next morning after the factory's run, with all the operational effectiveness of this factory, I can say, hey, what happened in the factory last night? AI comes back and says, you had a robot failure. Which robot? How many more robots do I have like that in the factory? What was the operational effectiveness of that robot versus the robots that I have here already? And I'm asking natural language and getting responses immediately about my factory, what's going on. And then you want to put a physics-based model behind it, because without the data and the context, it doesn't do you a whole lot of good. So now data and context, I could say, that robot failed. How do I reroute the factory automatically with a new process based on what you know about what I've done? those are real examples of new things beyond just what we have to add to the product. So I think it's got tremendous potential for all of us, and I think we're all going to have to be there very aggressively into our products.
Shankar.
So from our perspective, we pioneered the application of AI to EDA, and the ability to monetize is directly proportional to the sustainable differentiation that you can demonstrate. And if you look at some of the AI capabilities that we have rolled out and some of the gains that we have delivered with those AI capabilities, I would call it eye-popping. When we look at our design space optimization, which optimizes the digital implementation flow, and customers report 10-20% power improvement, that is almost getting to a half node improvement in power. And so when you bring that kind of value, absolutely you can monetize. If you look at the verification space, where we are demonstrating 2x reduction in compute cycles to attain coverage, and that essentially allows you to completely change your approach to compute for verification, you can absolutely monetize that. Or you look at the analog space, where you can cut down the time it takes to migrate analog circuits from one node to another by 3 to 4x. Again, it's sustainable value that can be monetized. So we definitely believe that the ability to monetize is proportional to the amount of differentiation, and as long as you can sustain it, obviously you can monetize it. And then with generative AI, we see an exciting opportunity to further monetize, because essentially you have a way now to accelerate the creation of collateral of all sorts, whether it's RTL collateral, UVM collateral, or collateral for different types of design steps, tech files. And again, all these translate to productivity improvements at a time where our industry is not producing as many engineers as we need for all the ambition that everybody has with respect to silicon and system design. So I think there's absolutely opportunity here to monetize these, both the generative AI innovations, as well as the base AI innovations.
Okay. So we've got a few minutes left, so I'll ask each of you to maybe give a 1-minute answer to this last question. Sorry for the constraint. But in EDA, you're used to constraints. So we have here on stage the 3 largest PLM companies, Siemens, PTC, Dassault. We have obviously the 3 largest EDA companies. We have 3 of the largest CAD companies. And there's all agreement on this phenomenon in one shape or another. But do you think that of all the various functionalities that you offer, the various 3-letter acronyms, CAD, PLM, CAE, SLM, ALM, that there necessarily should be or will be a single focal point or glue to make all of this happen? Does PLM have to be the focal point for convergence? Or is it core EDA or something else? Does it begin at CAD? Sorry to make you answer in a very brief period on what may be a very long question, but how do you think about the centrality of your strategy, or where the center of gravity, or whatever you want to call it, might be to effectuate convergence? Let's go in reverse order and start with you, Shankar.
Yeah. No, so I think we definitely would say in the silicon development side, the notion of having a vertically integrated platform across design and verification and test and manufacturing and sign-off and TCAD is absolutely critical, because these effects are getting more and more complex. And if you really solve these as 10 different problems with poor handoffs between them, you will leave a lot of performance on the table, power on the table, especially at a time when every little bit of performance and power matters. So really, from the silicon development side, we definitely use this term hyperconvergence, and that's really the fundamental basis of our silicon strategy, how to connect up all the way from architecture down to manufacturing in a hyperconvergent environment. And we don't really see, for example, PLM being broadly adopted in the silicon development side, because increasingly those users are focused on highly integrated platforms that are multi-capable. Now on the system side, we definitely acknowledge that PLM is almost the de facto way of building systems, and of course everybody has to plug into it, whether you're doing electronics work or electrical work or mechanical work. So I don't really see this as an overarching thing, but I would rather like the silicon development part, and then there's the systems development part.
Tony.
Yeah, I'm often asked, what's a typical customer look like? And I said, I'm not sure there is such a thing as a typical customer, meaning they might have the same vision, but they all start in different places, right? If I have a new product introduction problem versus manufacturing versus whatever. So maybe a common theme, but you want to bring it all together. So your question of where do you start? You start with PLM, where's it come? I don't know that it matters as much as what problem are you solving? Where's the pain point at the moment? And then the question is, how well is your product integrated? As you say, can you get a good data flow? Does it make sense? Can I finish my job, right? If you're not able to represent software, mechanical, whatever, in manufacturing, can I finish? And then the question is, do I do it all with one person, or am I open, right? And so a big part of our strategy is remaining open, but at the same time, there's things I can accomplish through our own software where it's highly integrated, where I can do it much maybe easier or faster, but you still have to remain open. So I think it's a balance of both.
Yeah, so I'd agree with the statement of openness. From PTC's perspective, I would say PLM is our backbone, and then feeding into that we have ALM, we have CAD, etc., etc. But that doesn't mean everything needs to be in PLM. Right? The point is you've got to be open to be able to retrieve the appropriate data from the appropriate source when you need it to get the appropriate insights you need. So openness is the key. In PTC's case, I would say PLM is the backbone there.
Yes.
Resonate with the comments. We look at product engineer as an engineering life cycle, and that needs to be managed. It could be done with different types of tools, but there is a need for orchestration. It could be designed and organized around managing IP, all the way from requirements to designs and associated data to physical realizations and associated data. It does take an open ecosystem, standard interfaces, open APIs, partners and vendors working together, and also for customers, scripting languages like Python that allows them to create, application-specific workflows.
Okay. Great. Philippe.
I would turn it to the client at the end to decide, but what I can tell you is that the transformation that is needed to become an experience factory is to reconnect people that are working today in silos. Not only engineering, as is mentioned, since the beginning, but connecting manufacturing, production, procurement, the guys who are computing the ESG, after service, etc. And I think it will be the topic of a platform, an open platform that connects people, ideas, and processes. And by definition, a platform is breaking the silos. It needs to be open. Just one figure at Renault, one of our clients was adopted the platform on SaaS. We have connected 72 of their legacy systems, and they're now creating experiences. So I think the word will come from the platform and the way to use it in a SaaS environment.
Okay. Last but not least, Mr. Beckley.
Yeah, I think it's incorrect to think that it's an EDA, SDA problem that can be solved. I think it's a customer enterprise knowledge that needs to be brought to the forefront on this, and how they want to use their data and how they want to reorganize their teams in order to be successful. Everybody's optimizing the chip, the package, the board, the system, the software, but they're rethinking all of that, and they're rethinking about how they can use tools from companies like ours, but also how they can use the knowledge that's inherent in all the data that they're generating. And to do that, they're going to have to restructure themselves just like we need to restructure the way we do development. I mean, I need to force my Virtuoso team to talk to my printed circuit board team, to talk to my multi-physics team. If I can't break down those walls, then I can't deliver the solutions that are needed. The customers have the same problem. So in the end, I think we're going to follow that. Just like you said, break down those silos. They're internal to us, but they're at our customers too.
Very good. Well, thank you everyone for attending. Very informative. We'll hope to do this again next year. And in the meantime, let's thank the panelists and